Let's get started. Welcome everybody to When Sharing Isn't Caring. My name's Russell Wolf. I'm a Google developer expert for Kotlin, and I've been using Kotlin Multiplatform since pretty much day one. So hopefully can talk to you folks about some of the stuff I've learned in that time. To kind of kick things off, who has tried Kotlin Multiplatform already? Good amount of folks. Who's using it in production? Nice. Who is hiring for it? Nice, let's talk later. Well, so for folks who are less familiar, so Kotlin Multiplatform is JetBrains, Kotlin's ability to run not just on the JVM, but also on other platforms. So on native platforms like iOS, on the web via JavaScript or via WebAssembly. And it's structured so that you can share what code you want to share, but still run everything within the native environment that you'd be running on if you weren't sharing code. So essentially, your shared code becomes just one more library in addition to whatever other native libraries you might be using. And that library might be as big or as small as you want it to be. So you could be doing shared UI with Compose and sharing 100% of your stack. But even still, you'll have a little bit of platform-specific scaffold on top of that, because in the end, it's kind of the platform itself that is going to launch your app and run everything. So, quick little note on acronyms, since I still see people using the KMM acronym every so often. KMM is not a thing anymore. It was for a little while, but it was referring to kind of specifically the mobile side of KMP. But it was deemed too confusing, so just stick to KMP, and if you're really not sure, just say Kotlin Multiplatform. So yeah, sorry that all of the documentation for like 2 years wasn't doing that. And a quick kind of just overview of what KMP looks like. I like the mental model of this Venn diagram where you have kind of your Android and iOS code and you have some overlap between them where they're shared. So the left side of this is the Android code that you're used to writing if you're just a native Android developer. And there's a subset of that is not platform specific. It doesn't know about Android, it doesn't know about the JVM, and that's able to be pulled out into this kind of separate common source, which can then also run on iOS, where it gets combined with the iOS specific features, so iOS's APIs, things that exist in Swift but not in Objective-C, and things like that. And the KMP toolchain kind of brings all of that together. So you build your Android app and it takes the common source in the Android source. You build your iOS app, it takes the iOS and the common source, et cetera. And of course, there's more to things than just mobile, but the Venn diagram starts to get too complicated. And we're at an Android conference. I'll be focused mostly on just on the mobile side of things for the purpose of today's talk. So most people, as they're starting to get into using KMP, writing KMP code, will ask some version of this question. How do I do whatever it is I might be trying to do in Kotlin Multiplatform? I see this question kind of all the time on Slack or on social media. And if you get one thing from this talk, I hope it's that this is not always the right question to ask. So yes, there's a bunch of different libraries that exist in the KMP space. It's a lot richer of an ecosystem than it was a couple years ago. And so yes, maybe there is a library that already exists there, or maybe there's something in the standard library that already kind of covers your use case. But maybe there isn't, and that actually will still be okay. And I should say too, if you do have a library that works for your use case, be grateful, good for you, because back when I was first started doing this stuff in 2018, there were no libraries. So a little kind of back in my day moment for me. But the thing you always have to keep in mind is underneath, like hidden underneath Kotlin Multiplatform is always your native platforms. So you can rather than asking yourself, what's the way to do this in KMP, you can ask yourself, how would I do this if I weren't in Kotlin Multiplatform? Or how do I do whatever it is I'm trying to do on my native platform? And that then is kind of the starting point for how you will do it with KMP. And this is very convenient because Android and iOS are both very mature platforms where people have spent the last decade and a half solving a lot of the problems that you might run into. And so you can leverage that. You can leverage that in your KMP project if you're willing to dip into the platform code side of things. And that's not always easy. Like you often end up needing to do some work to wire a common API around your two different native solutions. So you might need some kind of adapter layer. It might look a little bit funky. You might have to attach some Legos to some connects or something else weird. But fundamentally, if a native solution exists for what you're trying to do, there's not a technical barrier to using it from KMP. There's just whatever kind of extra wiring work you have to do. So when I talk about platform code, what does that actually mean? So here's a kind of a diagram of your the shared library that's usually kind of the center of your KMP app. So each of these boxes is a different source set. There's the common source, Android source, and the iOS source, and they get bundled together as they're showing in the previous slides. And the reality of this is a little bit more complicated than is on this slide because there's separation between Android debug versus release. There's different targets for iOS simulators versus the iOS device. And there's like main and test sources, but this kind of gives you a rough idea of the structure of things. And in addition to this library, oh sorry, I'm missing a step. So yeah, usually when you're looking at this diagram, usually the common code is going to be the bulk of what you're looking at. Like your goal is to share code. So usually in your shared library, hopefully the orange is where most of things live, and the platform parts are just kind of things that help you actualize that common code, whether it's kind of implementation code for interfaces that are defined in common, or other kind of platform-specific bits of functionality. But this isn't the only code that you have in your app. There's also generally a app module kind of on top of it on either platform. So you're building an Android app using the native tooling, or you're building an iOS app using the native tooling, and you're pulling your shared code in as a library dependency. And so I use gray here to represent the areas that are like blue. Blue was the iOS Kotlin, and gray is going to be Swift or Objective-C instead. Is going to be kind of where your real native iOS code lives. And the app layer is all platform-specific code. So that may be, like when you're adding platform-specific functionality to your app, that is also a place where it can live. And like you might see some projects that have kind of more of this setup where the Android app is actually being built and packaged from the shared module. I don't usually like that setup because you kind of lose the parallel between Android and iOS. But especially for apps that are like aiming at 100% shared code or maximizing shared code, you see that pattern sometimes. So just kind of be aware of it. But usually I go for this one instead. And of course, your shared library or libraries might not be the only things that your app layer is depending on. Like you can also talk to any other native dependencies that might exist, which could be yours or it could be third-party dependencies. And that's like one of my favorite things about Kotlin Multiplatform is that it's not making it any harder for you to do things like that. Your shared code is just one more library, and it's not having any wider impact on your architecture than that. And of course, in addition to your apps having other dependencies, your common code, your shared library, might have either a multi-platform dependency or might have other native dependencies. And so this kind of gives you like a bit more of a complete example of kind of where different bits of code might be coming from. And anything on here that isn't in orange is platform code. And one of the nice things here is a lot of this stuff might be stuff that you don't have to write. So if there are kind of existing libraries that work for your use case, like you might be able to just kind of pull those in and use them, whether they're multi-platform libraries or not. And other than this one in the middle, all of these things are native dependencies that are the same things that you might have been using if you weren't doing KMP. So just like really want to highlight, there's lots of options to leverage different platform-specific solutions to do things from your common code. And the platform code ends up being essentially the code that you, or kind of starts from the code that you would write if you weren't sharing everything. And your kind of worst case scenario ends up being similar to what you would have if you had separate native apps with some extra Kotlin mixed in to do some wiring. And this, again, is one of those things, as Kevin made a point of in his keynote this morning. It's one of the things that really de-risks KMP is you start from a place, especially on the Android side, where you're not really doing anything fundamentally different than you might have been doing otherwise. But once you have kind of pulled into platform code and written your common interface around it, now you have the superpower that you can do new things from your shared code. And that's like the real magic of things is kind of once you have that wired in, now you have new options. But you don't have to depend on someone else to do that wiring for you. You can do it yourself. So what are some kind of different teams obviously work in different ways. So what are kind of some workflows that you sometimes see for this stuff, and how does that impact what your shared versus platform code might look like? So one thing you see a lot of is two separate native mobile teams that have this big wall between them. And especially in bigger organizations, like this is often the starting point for trying to pilot KMP. And you're kind of going through this whole exercise where you have these siloed teams that are learning to work together, and you have a small but growing little bit of shared code in the middle of them. But you have these big existing code bases. And that existing code is kind of your starting point for your platform implementations. So what you're often doing when you're trying to kind of start sharing code in an organization like this is take some piece of logic that you want to deduplicate, figure out kind of how it needs to wire into each of the apps, write your shared interface around that, and kind of wire it back into your existing flows. And that interop and the ability to kind of keep it consistent with what was there before is really important. But of course, when you're working with separate Android and iOS teams, there's always a couple of developers like this sitting around. There's people who have spent their entire career learning Swift and learning iOS very well and want to continue leveraging that expertise. Similar to how a lot of Android and Kotlin developers have spent a lot of time learning Kotlin and want to leverage that expertise. And it's really important to remember that this person is not wrong. Like it's not wrong to have spent a bunch of time learning a skill and want to continue leveraging that skill. And the skill that they have is still really valuable. So like leaving some of your code base in Swift rather than kind of pushing for a 100% shared code kind of setup lets your existing iOS team continue to leverage the skill set and expertise that they have, and it lets them continue kind of leveraging the institutional knowledge that has been built up in their code base before you were starting to share code. And you shouldn't see that as a bad thing just because you don't get to 100% shared. And each team will kind of have a different tolerance and a different kind of sweet spot for where they want the line between shared and not shared to be. For example, I've worked with a team that, like, a lot of people like the idea of sharing everything up to the view models and then like just doing separate native UI on top of that. But I worked with a team that deliberately didn't want to do that. They went a layer lower because their iOS team found that they could build screens a lot quicker if they weren't sharing their view models, if they were building a native iOS view model and could kind of use the idioms that they were used to do that. So leverage that. Like if you have iOS team members who want to keep writing iOS code, let them do that. But you will want, like, ideally there are some people that want to kind of live on the boundary or kind of hop over that fence, because that's what helps you write kind of some of that binding and glue code. So you also sometimes have a scenario, and this is something I've run into a couple times on projects, where you have, you're not kind of starting from two equal mobile teams, but you're starting maybe from an Android app that doesn't have an iOS equivalent yet, and you want to move some of that Android code into shared so that you can start to build up that iOS app. One place where this has come up for me is a group that essentially had like a kiosk-style app that was running AOSP, and they wanted to be able to run it on phones. And once it was running on phones, it needed to run on both platforms. So we started kind of pulling bits of shareable code out of that Android code base, but not all of it was able to come out as easily. So some of that stays on the Android side and then needs to be duplicated on the iOS side. And when you're doing things like that, like, again, you really benefit from having, like, this is not a team that starts with a lot of iOS expertise, but you really benefit from having some iOS expertise to help with that migration. You also get teams that are kind of building new apps from the ground up using a bit of Kotlin and a bit of Swift. So often that looks like a lot of shared code, like still you're kind of making your decision about where you want your boundary to be with a Swift layer on top on the iOS side. So like you're, in this scenario, like almost always using Swift for UI and maybe for a little bit underneath it, maybe also for some stuff in your data layer that needs to talk to certain iOS-specific APIs. But if you if you start kind of pushing that shared code boundary up enough, then you might jump into that shared compose version. When you're doing shared compose, if you're really pushing for that 100% shared everything, you start feeling like you don't maybe need that platform code. But suddenly this question comes back up again. You hit some use case, some requirement you have in your app that doesn't have an existing library that can solve for it, or you have some feature that you need to build that depends on the specifics of one platform or the other. And so even if you're starting from a place of 100% shared code, once you hit a certain level of maturity and complexity, you're going to need some platform-specific stuff eventually. And this is a team that, if they're really kind of just Kotlin developers who want to do all Kotlin all the time, can get in trouble a little bit if you don't have any iOS expertise to kind of help you build out some of the iOS-specific code. So this has not been kind of an exhaustive list of all different team scenarios, because that is itself an entire talk. But hopefully gives you a rough idea of kind of some of the different modes that teams work in and where the platform-specific code comes in. And hopefully makes the point that pretty much any way you do things, you will need some platform code eventually. And you will need developers who are experienced with both platforms in order to write that code. So let's look at a little bit of code. So looking at kind of some patterns and kind of taking examples from different projects that I've worked on, trying to change names and things to protect the innocent. And also some examples from my own open source work, so not changing those names to protect the non-innocent. So I maintain this library called Multiplatform Settings, and it's essentially a key value store. So it wraps shared preferences on the Android side, it wraps user defaults on the iOS side, wraps various other APIs on other platforms. And the kind of default usage of it requires a little bit of platform specifics because there's different implementations on different platforms, and so you need to be on that platform to access those implementations. And this is nice and flexible when you want flexibility, but I also, over time, got the feedback that people who don't need that flexibility would like to be able to kind of run things just from common. And while I don't necessarily recommend that everybody do that, it was a nice thing to add as an option. And so I added an extra module with this common expect function that works as a factory where it picks a default implementation for you. So yeah, like it's less configurable than you would get if you're doing things from platform code, but it's convenient for people who don't care about that configurability. And it's a good example of a pattern that I see a lot where you have an interface in common, which is settings here. You have different platform-specific implementations of it, and you can either pick which platform-specific thing you want to use, or you can define an expect actual API that gives you a default. And it's like it gives you that kind of mix of both ease of use and configurability when you want it. So yeah, sorry, saying the points that I just made, but another kind of way of looking at this a little bit is like with this expect actual declaration, you're using platform-specific code to enable a new common API, and that's essentially how what expect actual is doing. Another example from the same library, deep in the internals of that NS user default settings, it needs to talk to iOS APIs that talk to an iOS integer, or I should say a Apple platform integer, because it's also running on tvOS and watchOS and all of those. And some of those other targets are 32-bit rather than 64-bit, and the integer size is different. So in order to make that all work on both 32-bit and 64-bit targets, I had to add these extra kind of expect actual functions that kind of convert between int and long when you need to deal with the 32-bit to 64-bit issue. So this set integer call on the bottom on 32-bit targets is a 32-bit int, and on 64-bit targets is a 64-bit int, which is a Kotlin long. So this is a pattern where you don't have any of that. You don't have any kind of external visibility of it. So there's no top-level API that's aware that there's kind of different platform implementations. But you're able to kind of use expect actual to hide those platform differences while still doing the right thing for the platform that you're running on. Another pattern that I've kind of used in multiple different apps, so this is kind of a hodgepodge example taken or hodgepodge kind of demo taken from different examples. If you're writing some custom analytics code, you might want to have a common kind of analytics manager class that knows about what your different event types are. So it has awareness that you want like an open app event and a sign-in event and maybe some others. But it doesn't know how to actually log an event because that's coming from some platform-specific API. So that might be coming from whatever analytics vendor you're using who doesn't care about KMP, and so they have separate Android and iOS SDKs that you're building against. So you can kind of write this, have this writer interface that you inject into your parent class and give that different Android and iOS implementations. And if you're working with multiple vendors, like you might have more than one of these on each platform, or you might have some combined one that writes to multiple things at once. But the overall pattern here that I see in see across a bunch of library development stuff too, like you see it in KTOR and in SQLite as well, is you have kind of a platform-specific engine that you inject into your common code. And that engine knows about like the specific operations that it needs to do in order to do whatever the common code needs. And yeah, you inject that via dependency injection or through the constructor. Final example here, this was from that project where we were starting from an Android code base and moving it into iOS. One of the things this app needed to do is it had this complicated sync logic where it was often working in like poor internet areas, and it would have to, it would kind of build up a database of events that it needed to sync later on. And after some work, like we were able to make the sync logic relatively platform agnostic, but there was still this socket connection class that was talking to the Java socket APIs, and wasn't super easy to re-abstract because it was doing a lot of kind of complicated operations internally, and we didn't want to change it too much because we didn't want to risk kind of breaking some implicit assumption that the code was making and cause problems for the existing app. But what we were able to do is move that connection class also into common by pulling out kind of a separate socket interface that was like really a direct wrapper around the Java socket APIs, and then we were able to add a iOS implementation of that separately. And a nice piece of this pattern here is like the socket connection class needed to be able to create and destroy things. It wasn't just, you weren't just passing it a socket, it also needed to kind of create its own connections. We were, so by having this kind of like separate factory interface, we're able to give the common code the ability to do that. So like just a socket interface doesn't have a constructor, but you can add a second interface, so it does. So it essentially does. So yeah, that factory lets you create platform-specific instances, and then you can, then we were able to kind of move the more complex logic into common code. One final example. So this is from another old open source project of mine. I had a need to send kind of reminder notifications. So it was just local notifications, so not dealing with talking to an API or anything, or not dealing with push notifications. But we still wanted to be able to kind of take a list of reminders from our common code and kind of schedule them to be displayed in a platform-specific way. And what that ended up looking like is we just had this notification repository that we could subscribe to that would like give a flow of the list of reminders that we want. And then Android is able to subscribe to it in an Android-specific way, schedule some things with Work Manager to do the background work that it needed to do some processing. And iOS had a little bit of extra plumbing that it needed to do, but it had it was talking to kind of so some of the iOS BG task APIs and things to be able to schedule notifications on that platform. And so this is an example where there's it's very heavy on the platform code side. Like there's a little bit of shared code that's your kind of source of truth. But sometimes that's all you need. And sometimes, especially with notifications, when you might want to display things differently or to kind of make use of platform-specific UI bells and whistles that you have on notifications, it can be convenient to just leave it all completely in, or leave a lot of it in platform code, and just have your kind of shared bit in the middle. And yeah, if you don't hide from the fact that you're on these two different platforms, then you can use the full benefits of each platform. Sorry, I made those steps already. Wrapping up a little bit, what are some kind of overall lessons from all of this? The big one for me is like anytime you're writing code, whether it's multi-platform code or not, like you are still running on some specific platform. So in your multi-platform code, use that fact. Like don't be afraid to inject some platform-specific logic. It's often like possible to put most of your code into common and just have like a couple little bits of platform-specific stuff that are driving it. But you're not taking full advantage of KMP if you're not using platform code when you need to. Another lesson to keep in mind is iOS code needs iOS developers. If you're just trying to do everything from an Android perspective, you're going to have a bad day eventually. As I said before, like the iOS side, iOS developers have a lot of experience on their platform, and you can gain a lot by leveraging that rather than trying to hide it. And lastly, I'll take a little bit of inspiration from JFK and say, that's not what KMP can do for you, but what you can do for KMP. Kevin in his keynote was making the point about like the need for more libraries and the kind of opportunities to contribute things back to the rest of the ecosystem. And if you're writing platform-specific code and you're writing some common abstraction around that, like that is the starting point for your library. So if you're writing your first KMP app and you run into that issue of how do I do something in KMP, and you figure out how to do it from your platform code, why not publish that? Like writing platform code is how you get to there quickly. So thanks for coming to my talk, and I'd be happy to answer some questions.